today we're going to be completing the topic of circular motion in our second lesson, linking back to ideas we established in lesson 1 about objects moving in a circular fashion at a constant speed. I've included the specification again if you wanted to pause and read that. And today we're going to be looking at the last 3 points of the specification, introducing the idea of centripetal force, centripetal acceleration, and the equations that are required for manipulating data within exam questions. Starting with centripetal force, and we established in lesson 1 this idea that if an object's moving in a circular motion, that it will have an ever-changing velocity because its direction is constantly changing. Now from that we can establish that if its velocity is changing, it must be accelerating, and if it's accelerating there must be an overall force acting on it, and that overall force is what we refer to as centripetal force. And the centripetal force is constantly acting towards the center of the circle. Right, so we can define our centripetal force. It's the resultant force that acts on an object that is moving at a constant speed in a circle. So although its speed is constant, its velocity would be changing. And obviously that is different to linear objects, where if they were moving in a straight line at a constant speed, that would mean that there would be no resultant force. Now, this centripetal force always acts towards the center of the circle. So although its value would be constant, its direction would be ever changing. So when an object is there, its velocity is in the direction of VO, and the force is acting perpendicularly at right angles and acting towards the center of the circle. And obviously a moment later, when that object's moved to another point on the circumference of the circle, the direction of that force will change because the velocity has changed, and therefore we get another right angle or perpendicular relationship as we move around the circle. So the centripetal force acting towards the center, and the velocity or the momentary velocity acting perpendicularly at 90 degrees. As I mentioned before, if we have that force acting, we must therefore have an acceleration. So this is a simple application of Newton's second law, that if we have a force is equal to the mass times the acceleration, and that idea that the force is proportional to the acceleration produced. So our first equation is a standard equation supplied for exams in your data booklet, but we should be able to manipulate this in order to create a second equation. So we use our equation from lesson 1, which is that V equals omega r. In our equation we have V squared, so we can square the entire of this. V squared equals omega squared r squared, and we substitute that into our equation for acceleration. So the V squared disappears and becomes omega squared r squared. And that's all divided by r. So we can cancel one of the r's from the top with one of the r's from the bottom to produce a second equation that the centripetal acceleration will be equal to omega squared r. Now that is a manipulation that you should be able to perform in exams, so you will need to practice the substitution and squaring of V equals omega r in order to create that second equation. We can do this very similarly for centripetal force as well. So we're going back to that idea of Newton's second law, F equals ma, force equals mass times acceleration. So if the acceleration is V squared over r, then the force must be m V squared over r. In the same way, we can do that with our manipulated version of the acceleration. So if a equals omega squared r, F must be m omega squared r. and that produces a further 2 equations, giving us 5 in total, 4 from this lesson and 1 from lesson 1. It's important to realise that, again, we can manipulate this into the second force equation using V equals omega r. So that manipulation I mentioned on the previous slide can be used both for the acceleration and for the equations for force. And you should be able to do both in order to create equation 2 for force and equation 2 for acceleration. Okay, so that is the entire specification for this topic. I've listed the 5 equations at the bottom just as they're found in the specification. They are the majority of the work for this topic. There's a couple of definitions to know that we've been through, but sorry, I made a mistake there. That 2 should be superscript because it's squares, not a multiple of 2. But using those equations correctly and deciding which ones to use at an appropriate time is the main skill for questions and exams on this topic. So I've included in this task another exercise for you to try that's based on previous questions and exams. If you have any problems with them, drop me a message and I'll do my best to help. Thanks.